Hi, good afternoon, class, and welcome back to Math Csec for 2023. Today, what we're going to be learning is about computation, and we're going to begin with fractions. So, students, I would like you to make sure and take notes. It's going to be a bit different from here on out. I would like you to write down the notes that I am writing down on the board, and then afterwards, once the topic is completed, I will send you a document with all of the notes. I want you to write down the notes so that you will be able to have a copy of it with you, hard copy, written down, so that when you are doing your homework, you can look back at the examples and so forth, and you will know what to do, and you would not have to wait on the notes. At the end of every topic from here on out, what I will be doing is that I will send you or something like a revision aspect of the notes. So with all the important formulas and rules and one or two examples that you need. And as well as always, during and after each topic, we will be doing past paper questions. So today's topic is going to be on fractions. I want you to write down these notes, and afterwards I will explain them. So I'm going to keep my mic muted until then. Cameron, when you reach the last one, just let me know and I'll change the slide. All right. So Cameron, I don't know if you heard me before because I can't remember if I unmuted my mic. What happened is that when you're finished writing, taking down this note, all right, I'm great. And we'll keep up with this pace continuing forward. I'll come back to the next slide in a minute, Cameron. So while we're dealing with computation, one of the things that we will come across a lot in maths is fractions. We can represent fractions using different forms. So fractions can be a part of a whole, such as with 3/8. You have this circle, which is divided equally into 8 parts. And what is shaded is 3 parts of that 8. Now, the top number is known as the numerator, which represents how much of the whole is represented by the amount of parts. And then you have the denominator, which tells us how much that whole is divided into. Now, what we can think of when it comes to fractions is really sort of division, right? It's just written in a different way, especially when we are looking at as a part of a whole. Fraction can also be used to be represented as part of a set. Here we have a set of 7 circles, and we have 5 out of 7 circles that is shaded. So we can represent this by saying 5/7. And what we can also do is we can represent fraction as a position on the number line. So between 3 and 4, this is divided into, let's say, 1/3, 2/3, or 1/3 plus 1, or 2/3 plus 1, and so forth. So this would be in the dead center, it would be 3.5. Around here, so it could be 3.25. Around here, so it could be 3 3/4. It can be divided into any amount and be placed onto the number line to assist us with further calculations. Another way that we can also represent fraction is as a comparison between two quantities. For example, if we wanted to know the ratio of girls to boys in a class, right? And we have two, three, this means that for every two girls, there are three boys. And we can say that the number of girls is 2/3 the number of boys, or 3/3 the number, three halves the number of girls. Any questions, Cameron?
No, miss.
Okay, then great. So I'm going to continue with the notes, and then I'm going to stop when I reach a particular point and explain again. So continue writing. Cameron, are you finished writing the notes? Okay, great. So when we're dealing with equivalent fractions, we can say two fractions are equivalent if they represent the same quantity or value, but come from different families. Now, when we're speaking about fraction families, we mean that they all have the same denominator. Now, we're using this example. 2/3 and 8/12 are equivalent because both represent the same portion of one whole. And we have this diagram here. We have this diagram here, which we use to represent this, right? So we see here, when we draw a circle and we divide one circle into 12 parts and another circle into 3 parts, and we shade 2/3 of the circle or 2 out of the 3 parts and 8 out of the 12 parts, they have the same value, or they have almost equal proportions, right? Now, what we have to understand is that when dealing with equivalent fractions, although this is what makes the denominator different, if you recall in this first slide, the denominator is the amount of parts that the whole is divided into, and the numerator is the amount of parts that we are using from that whole. So that's how we get 3 out of 8. So when dealing with equivalent fraction, the reason why we look at fraction families would be 1/3, then 2/3, and then of course 3/3, which is the entire whole. Here we have 12ths. So this 8/12 belong to the 12th family, right? And that means you'll have 1/12, 2/12, 3/12, all the way to 12/12. Just because it has two different fraction families or two different denominators, and it's been divided into the entire whole is divided into two different types of division. When we are dealing with the equivalent fraction, 2/3 of this circle is always going to be equal to 2/3 of this circle, regardless of how much this circle is divided into. And likewise, 8/12 from this circle is gonna be 8/12 of this circle, regardless of how many parts this circle is divided into. The value of a fraction is not changed if both the numerator and the denominator are multiplied or divided by the same non-zero number. So let's look at, actually what I'll do, I'll make this bigger. Great. So let's look at this. We continue with this example here. We have 2/3. Now this, instead of having to go through everything and shade it to be able to get the equivalent fraction, we wanted to see what fraction was equivalent to 2/3. We can use what is called a multiple, either the lowest common multiple or the highest common factor to multiply to find out, well, what other fraction will be equivalent to this. So in this case, it will be 2 multiplied by 4 will give us 8 for the numerator, and 3 multiplied by 4 will give us 12, and that's how we got 12/8. One thing I want you to notice, we are multiplying the numerator and the denominator by the same number. We are not using different numbers. Likewise, if we want to find a lesser equivalent value of 8/12, right? What we are going to do is instead we are going to divide, not multiply, because we are looking to get a reduced fractional equivalent to this fraction. So we are going to divide by the same whole number and both the numerator and the denominator once more. So it's going to be 8 divided by 4 gives us 2. 12 divided by 4 gives us 3. When division is used, this process is called reducing the fraction in its lowest form. A lot of times when you do division, when you reach into other aspects of maths, the CSEC, you need to simplify your answer, reduce your answer to its lowest form, and you may find that you do this as well. Any questions?
No, miss.
Okay, so we're gonna move on. What we're gonna do is move on to the next slide, and I will write the notes, and as I'm writing, you write as well, and then when I'm done, I'll explain. So Cameron, as we are running out of time, and 10 minutes time, the timer will stop. As soon as I'm done writing this note, what we will do is I will explain it to you, and then I will end the meeting, and you can log back in. And when you log back in, we will pick up from where we left off. Right. So before the meeting ends, this is what I want to go through with you. Now, when it comes to mixed numbers and improper fractions, we must first understand what a proper fraction is. A proper fraction is part of a whole. And in this case, the numerator is of a lesser value than the denominator. So some examples of proper fractions that we did previously in class is 3/8. It is, what else? We also did 2/3 and 8/12. These are what we all call proper fractions because the numerator, it is shaded, it is less than the amount that is divided into. So instance, 8/12 means that 8 parts of the entire 12, 12 parts is what is shaded and what we're working with. However, when it comes to improper fractions, it is more than one whole. The numerator in this case is of a greater value than the denominator. So our example that we had that previously from is when we were looking at how we could represent fractions. And when we were representing fractions as part of a ratio, we saw here, but when we had the ratio as 2:3, for every 2 girls, there are 3 boys. When we were representing the boys as 3/2, the number of girls, this figure here would be a perfect example of a improper fraction because you have one whole and then a fraction of another whole combined. So basically what you can think of an improper fraction is that you have multiple wholes of something. In this case, let's say it's a pie for analogy's sake. You have multiple pies. So let's say you have 6 pies and you're at a party and you have to divide it. 2 of your guests came and asked for 2 of the apple pies. So they wanted 2 slices each. So that would be 4 slices, 4 over, let's say you divided each apple pie into 4 or 6. That would be 2/6 of 1 pie because you gave 1 slice to each person to make 2. You still have 6 pies. You still have 5 whole pies remaining. Now, when you represent that as a mixed number, it would be 5 and 2/6. But when you represent that as an improper fraction, it would be, let's say you were going to divide all the pies into 6 parts. That would intend to be, that would be 34/6. And 34/6 means that we have other whole pies remaining that still needs to be divided, that still needs to be shared. And that's why it's an improper fraction. It represents more than one whole. Any questions, Cameron?
No.
Okay, that's great. So what I'll do is that I'll end the meeting here and then I will, as soon as I restart the next meeting, I will message you. Just log back in immediately because I'm gonna restart the meeting now, okay?